What if the universe itself broke its own rules and didn't care? Imagine you're sitting on your porch on a clear Texas night, staring up at a sky full of stars, and everything looks perfectly normal, orderly, predictable. Like the cosmos has it all figured out. But hiding out there, beyond what any telescope has ever shown us, are things so bizarre, so flat out wrong by every law of physics we know, that NASA scientists have literally said, this shouldn't exist. We're talking about objects that defy gravity, energy that appears from absolute nothing, and structures so massive they make our entire Milky Way look like a grain of sand on Miami Beach. Welcome to Space Secrets, the channel where we take the wildest corners of the universe and break them down so clearly, you'll feel it in your bones. Today, we're diving into 10 of the most horrifying, mind-bending things in the universe that physics says flat out cannot exist. And yet, there they are. Trust me, you're going to want to stay all the way to the end because number one will completely rewire the way you see reality itself. And if that sounds like your kind of ride, hit subscribe right now because on Astromat, this is just the beginning. Think about the last time something surprised you so much it stopped you dead in your tracks. Maybe it was a plot twist in a movie, or the moment you found out your
بعد
favorite
نبود خدای با
sports team
ربات پاره ترس
comeback
داره
that made
قیچی
absolutely
زدم
no sense.
قبول بکنین از من
That feeling, that gut punch of, wait, that's not supposed to happen. That's exactly how physicists feel when they look at certain things in the universe. But here's the difference. In football, improbable things still technically follow the rules of the game. In physics, the rules aren't suggestions. They're the operating system of reality itself. It starts simple. Physics, at its core, is our best attempt to describe how everything in the universe behaves, from electrons too small to see, to galaxies too large to fully imagine. Over centuries, brilliant minds, from Newton mapping gravity to Einstein rewriting space and time, built a framework so reliable that NASA uses it to land rovers on Mars with pinpoint accuracy, to send Voyager 1 past the edge of our solar system, and to predict the orbit of every satellite currently circling Earth. These laws aren't fragile. They've been stress-tested in laboratories, proven across billions of light-years of observations, and confirmed by some of the most sophisticated space science instruments ever built by human hands, including the James Webb Space Telescope right here in the 21st century. So when we talk about something that should not exist according to physics, we're not being dramatic. We're saying these things look the universe's own rulebook dead in the eye and laugh. There are specific boundaries physics draws with absolute confidence. Energy cannot be created from nothing. Matter cannot just vanish without a trace. Cause must always come before effect. Objects with mass cannot travel at the speed of light. These aren't opinions. These are the foundations of every space discovery, every NASA mission, every calculation that has ever successfully predicted how the cosmos behaves. And yet, the universe, in all its terrifying, awe-inspiring freedom, appears to have built things that make even our most trusted equations sweat. Now that you understand what the rulebook says, let's meet the monsters the universe was never supposed to build. Let's play a thought experiment. Imagine you're an architect and you've been given a very specific set of building materials, a fixed amount of steel, concrete, and time. Physics tells us the universe had the same deal after the Big Bang, a set amount of matter, a set amount of time, and a very strict blueprint for how large and how fast structures could grow. So when astronomers started finding black holes, not just big ones, but obscenely, grotesquely, impossibly massive ones, the blueprint suddenly looked like it had been written in pencil. Here's the science fact that should genuinely unsettle you. At the center of most large galaxies sits a supermassive black hole. Our own Milky Way has one, Sagittarius A star, and it weighs about 4 million times the mass of our Sun. That already sounds insane. But then NASA and observatories around the world started detecting black holes weighing not millions, but billions, sometimes tens of billions, of solar masses. And some of these monsters existed when the universe was less than 1 billion years old. That is the problem. A black hole grows by consuming matter. And consuming matter takes time. The universe, in its earliest chapters, simply had not given these objects enough time to eat their way to that size. It's like finding a 1,000-year-old oak tree in a forest that was planted last Tuesday. The Chandra X-ray Observatory, one of NASA's crown jewels of space science, has spent decades imaging these cosmic giants. And the more data it returns, the more the mystery deepens. Some of these ultra-massive black holes appear to have formed and grown at speeds that our best models of black hole physics cannot fully explain. And it isn't just black holes. Magnetars, the collapsed cores of dead stars, generate magnetic fields so powerful that if one sat halfway between Earth and the Moon, it would erase every credit card on the planet and disrupt the iron in your blood. They spin dozens of times per second and release more energy in a single blink than our sun produces in 100,000 years. Physics allows them, barely. But the conditions required to create them stretch our models to their absolute limit. The universe, it turns out, is not just building things bigger and more powerful than expected. It's doing it faster and more efficiently than the laws of physics say it should be able to. Now that we've met the physical monsters, it's time to go even deeper, into the strange territory where energy itself starts playing by a completely different set of rules. Here's something that will quietly break your brain if you sit with it long enough. Picture your kitchen. Right now, in the space between your coffee mug and the edge of the counter, in the air in front of your face, in every cubic inch of what you'd call absolutely nothing, the universe is quietly, constantly, violently churning. Particles are popping in and out of existence. Energy is appearing and disappearing so fast that our instruments can barely catch it happening. And the laws of physics, rather than forbidding this, actually predict it with stunning mathematical precision. This is called quantum vacuum fluctuation, and it is one of the strangest confirmed science facts in all of modern physics. Here's the intuition. In the quantum world, the world of the unimaginably small, Heisenberg's uncertainty principle tells us that you can never know both the energy of a system and the exact moment in time, with perfect precision simultaneously. Uncertainty isn't a flaw in our instruments, it's a feature of reality itself. And that uncertainty creates a loophole, a cosmic permission slip, for energy to exist briefly where there was nothing. Now scale that up. Across the entire observable universe, 13.8 billion light-years in every direction, that same quantum churning is happening everywhere, all at once, in every pocket of so-called empty space. And here is where physics starts sweating again. In the late 1990s, two American research teams, one led from the Lawrence Berkeley National Laboratory in California, made a discovery so shocking it earned a Nobel Prize. They were studying distant supernovae, using them like cosmic measuring sticks, expecting to find that the universe's expansion was slowing down due to gravity. Instead, they found the opposite. The universe isn't just expanding, it's accelerating. Something is pushing everything apart, faster and faster, with each passing moment. That something is what scientists now call dark energy. It makes up roughly 68% of everything in the universe. NASA's WMAP and later the Planck mission helped map its influence across the entire cosmic landscape. And yet, we have no idea what it actually is. Our best guess is that it's connected to the energy of the quantum vacuum itself. But when physicists run the calculation, the theoretical prediction and the observed value are off by a factor so large it's considered the worst prediction in the history of science. The universe is not just bending the rules with individual exotic objects. It is running on a form of energy that physics can measure, map, and confirm, but cannot yet explain. And if that feels unsettling at the scale of energy itself, wait until you see what the universe has been quietly assembling at the largest scales imaginable. Let's put the scale of what we're about to discuss into perspective. If you took every single person alive on Earth today and asked them to stand in a line, that line would stretch to the moon and back several times. Impressive, right? Now imagine a structure so large that our entire Milky Way galaxy, 100,000 light-years across, containing 400 billion stars, would be a single, solitary dot on its surface. Not a notable dot, just a dot, invisible without a magnifying glass. That is the kind of scale we are dealing with in this section, and that is exactly where physics starts losing its composure. The standard model of cosmology, the universe explained in its most complete and carefully tested form, makes a very specific prediction. After the Big Bang, matter should have spread out and clumped together gradually, pulled by gravity over vast stretches of time, forming galaxies, then galaxy clusters, then larger structures called superclusters. But there is a ceiling, a hard cosmic speed limit on how large any connected structure can grow, given the age of the universe. That ceiling is roughly 1.2 billion light-years. The Hercules Corona Borealis Great Wall laughs at that ceiling. Discovered by American and Hungarian researchers and confirmed through gamma-ray burst mapping, this structure stretches an estimated 10 billion light-years across. Let that number land. 10 billion light-years. In a universe that is only 13.8 billion light-years in observable radius. This single structure takes up a jaw-dropping fraction of everything we can see, and it should not exist. The universe has simply not been around long enough, and gravity has simply not been strong enough to assemble anything remotely close to this size. And then there are the voids. The Bodas Void, first discovered by American astronomers at Kitt Peak National Observatory in Arizona, is a region of space roughly 330 million light-years across, containing almost nothing. No galaxies, no gas clouds, no meaningful structure of any kind. Just silence. Our models of how matter clumps and distributes after the Big Bang cannot cleanly account for emptiness on this scale either. NASA's large-scale cosmic surveys, including data from the Sloan Digital Sky Survey and observations fed through the James Webb Space Telescope, continue to reveal a universe whose large-scale architecture keeps quietly, persistently defying our most confident predictions. The cosmos, it turns out, didn't just break the rules once or twice in isolated exotic corners. It built its entire large-scale skeleton in ways that make our equations uncomfortable. And now, with all of these impossible things laid out before us, it's time to ask the question that changes everything. What if our laws of physics aren't wrong, but simply incomplete? Here is the most uncomfortable truth in all of modern science. We didn't just find a few anomalies. We didn't just stumble across one or two cosmic oddities that needed a footnote correction in a textbook. What physicists and astronomers have been quietly assembling through decades of NASA missions, groundbreaking American research institutions, and some of the most sophisticated space science instruments ever built, is a pattern. A persistent, growing, undeniable pattern of a universe that keeps producing things our best theories say it shouldn't. And that changes everything about how we have to think about physics itself. Consider the Hubble tension. Right now, today, there is an active, unresolved crisis at the heart of cosmology. Two separate methods of measuring how fast the universe is expanding keep producing different answers. Teams using the cosmic microwave background, the faint afterglow of the Big Bang, mapped exquisitely by NASA's WMAP satellite, get one number. Teams using distance measurements from Cepheid stars and supernovae, including research built on data from the Hubble Space Telescope, get a consistently higher number. These aren't rounding errors. The gap is statistically significant, and it has refused to close for years. Something is wrong. Or more precisely, something is missing. Think about it like this. Imagine you built the most accurate GPS navigation system in history. It works perfectly across every road in America. But then, in certain cities, it keeps putting you 2 blocks off from where you actually are, every single time, without fail. At some point, you stop blaming the signal. You start wondering whether your map of those cities was ever fully correct to begin with. That is where physics stands today. The standard model of particle physics, the most precisely tested scientific theory in human history, cannot account for dark matter, cannot explain dark energy, and cannot fully reconcile quantum mechanics with general relativity. These are not minor gaps. Together they mean that everything our physics currently describes accounts for less than 5% of the total content of the universe. Less than 5%. The James Webb Space Telescope is now sending back images of galaxies in the early universe that are larger, more mature, and more organized than our models predicted they could possibly be at that age. Each image is a quiet, beautiful, devastating challenge to our current understanding. And here is the most thrilling part of all of this. Every single impossible thing we've explored in this video isn't a dead end. It's a door. A door that the greatest scientific minds in America and around the world are walking toward right now, with better tools, sharper questions, and a universe that is clearly not done surprising us. Physics isn't broken. It's evolving, and the universe, in all its horrifying, awe-inspiring impossibility, is the greatest teacher we have ever had. Now let's bring it all together and count down the 10 specific things that should not exist, but do. So let's take a breath and sit with what we've actually covered today. First, the laws of physics are not suggestions. They are the most rigorously tested, most carefully confirmed framework for understanding reality that human civilization has ever produced. NASA lands rovers on Mars using these laws. We split atoms using these laws. We built the internet using these laws. They work. Second, and this is where it gets profound, the universe keeps producing things that push those laws to their absolute limits. Impossibly massive black holes that grew too fast, quantum energy flickering in and out of empty space, a mysterious dark energy accelerating the expansion of everything, everywhere, right now, including the space between galaxies billions of light years from anything we'll ever visit, and structures so enormous that our best cosmological models look at them and quietly panic. Third, and this is the one I want you to carry with you, none of this means science is failing. It means science is working exactly as it should. Every universe mystery we uncovered today is not a crack in human knowledge. It is the frontier of it. Right now, NASA's Nancy Grace Roman Space Telescope is being prepared to map the large-scale structure of the universe in greater detail than ever before. The James Webb Space Telescope continues to send back images that rewrite what we thought we knew about the early cosmos. American research teams at institutions from Caltech to MIT to Fermilab are working every single day on the questions this video raised. This science explained in lecture halls and laboratories across this country is not abstract. It is the living edge of what it means to be a curious species on a small planet, staring up and refusing to stop asking why. And here is the thought I want to leave you with. Everything we explored today, every impossible object, every rule-breaking structure, every universe mystery that made our equations uncomfortable, all of it exists inside a cosmos that has been running for 13.8 billion years without once asking for our permission or our understanding. We are the universe becoming aware of itself, and the fact that we can look up at something that should not exist and feel wonder instead of fear. That might be the most remarkable thing in all of space exploration. Thank you for watching Astro Matt. If today's video made you see the universe even slightly differently, hit that subscribe button right now, because this is exactly what we do here every single week. Clear explanations, genuine wonder, and the kind of space and physics content that respects your intelligence and rewards your curiosity. New videos drop every week on Astro Matt. So stay curious, stay subscribed, and I'll see you in the next one. And that's a wrap on today's video. And honestly, I just love that you were here for it. The fact that less than 5% of the universe is made of the stuff our physics can actually describe. And yet NASA and American scientists keep pushing further into that unknown every single day. That never gets old to me. That never stops being incredible. This is why space exploration matters. Not just for the technology, not just for the missions, but for the questions. The ones that make us feel small and alive and endlessly curious all at the same time. I genuinely love exploring this stuff with you, and we are just getting started. I'll see you in the next one.